Chapter 3, our last section, and similar to many chapters, this chapter ends with something about solving problems. In this case, the strategy is making an organized list. An island will be divided by 4 landowners into 4 pieces. How can this be done so that each piece shares borders with the other 3? So I've got an island, and I want to cut it up into 4 pieces. Let's think about how I might do this. So if I simply do this, each one shares with the other 2, so that doesn't work because this one is not sharing with that one. How else might I do this? I don't know. So this is a problem to think about. I don't want to spend the time thinking about it now, and I don't know the answer. But I bet somebody out there does, so when you get into class, please tell me. How about this one? Find x so that 3 raised to that power will give us 729. Okay, for this, we're going to want to pull over a calculator. Let me get it. All right, so if I say 3 raised to the, well, let's be very conservative. I know this isn't going to be right, but how do we do raised to? We use this little button right here. Everybody see it? Let's try raised to the 3rd power. That's going to give us 27. That's not enough. 3 raised to the 4th power gives us 81. That's not enough. All right, 3 raised to the 5th power. Now, we might be getting somewhere. Oh, not quite, but I think we might be getting close. What do you think? 3 raised to the 6th power. There it is. So x equals 6. So what was that? That was try, test, revise. And we did that several times until we arrived at the one that would work. If a letter could be used twice in the same license plate, would there be more or fewer choices than if it could be used only once? Well, let's think about a license plate which only had, let's say, we'll keep it really simple, 3 letters. 3 letters. And if I could do A, B, C, and I could do that would be all I'd have, wouldn't it? I mean, I could put them in different order, but that's all I would have. However, if I could use a letter twice, I could have A, B, and I could have, let's separate these, and I still could have A, B, C. I don't even have to go down through them to be able to answer this. It's not asking us how many more, it's just more or fewer. I would have more. If I could use a letter twice, I would have more choices. Okay. How many choices would there be if the license plates consisted of only 4 letters without repetitions? How many choices would there be? Let's look at the answer. I'm getting really lazy today. 24 choices. 24 choices. Let's see if we can figure out what they are. We could have A, B, C, D. We could have B, C, D, A. We could have C, D, B. Oh, I'm already messing it up. In other words, we could keep going and get ourselves 24 of these, on and on and on and on and on. I guess the point here is that by making a list, and this wasn't really well organized because I started with a certain idea in mind, and I hope you can see what it was. It was that I would just keep shifting one letter, and then when I got here I lost track of what I was doing. I should have done that, and then I would have gotten here to D, A, B, C, and I would have gone through these 4 letters with that strategy. And then I would start out, I'd scramble it a little bit, and apparently I'd be able to scramble it 6 different ways, and then work down all 4 letters. I could use the same approach. So I guess the key is an organized list. Have a plan of how you're going to approach it. There are 5 finalists in a tennis tournament. Each finalist will play all the other finalists. Okay, so we've got all these people. A, B, C, D, and E. Each finalist will play all the others. Each one will play all the others. The player who wins the most matches wins the tournament. How many matches will be played? Well, if A has to play all the others, it's going to play against B, and they're going to play against C, and they're going to play against D. They're going to play against E. Now B has already played against A, but they haven't played against C or D or E. Now C has played against A and B, but it hasn't played against D, and it hasn't played against E. D has played against 3 of them, but it hasn't played against E. And E has played against all of them. So for all of them to get to play all the other finalists, we have to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, this isn't actually E playing against, no, that one doesn't count, because E has played against the other 4 right here. So 1, 2, 3, 4, 7, 9, 10. So how many matches will be played? Well, I figure it's 10. Let's see. I made these slides one summer. What did I say back then? 10. Okay, well that's reassuring. Hints for the assigned problems. Draw a diagram showing dimensions. Okay, these are the problems that you have to do for homework, so you might want to take a moment to write these down. So this is for number 3, this one's for number 6, and this one's for number 8. Maybe it would help if I read them. Go ahead and write this down. 3. Draw a diagram showing each dimension. Number 6. Draw a diagram. Getting familiar. Showing different lengths that can be made with a sheet of paper. Oh, that's such an interesting problem. You know what's nice about this? We get away from some of the just plain old calculating. We get into really thinking, trying to solve problems. Number 8, make an organized list of all the possible codes. Okay, so those are the hints for the problems that you have had assigned to you. And here are all the problem-solving techniques that we are taking a look at in this course. We certainly know try, test, revise, right? And we practiced it in this little session here. What's the next one we're going to come to? I guess it's going to be in chapter 6 that we're going to come up against another one. So right now, we've done draw a diagram, and that's always useful. Guess and check, and making a list. We're done. We're done early. It's only fair because some of the other lessons, they've been really, really long.